Okay, hello everybody. This is update number 3. I have been looking all over the internet at solutions to my problem, and what I have learned is that, what I've seen is that pure sine wave inverter has got a surge wattage of 10,000, and what it's pushing out is 120 volts at 15 amps, 120 volts. So I have got the beer fridge, both garage door openers, and some chargers hooked up all at the same time. So they all run on 120, and they all have various different wattage requirements. But this should be able to push out enough amps to run everything. And I couldn't figure out why. So on the internet, they said the reason that you're having a problem is because this 30 amp charge controller, 30 amps doesn't mean what it can accept. The 30 amps means what it is pushing out of the charge controller to your load. And that was the eureka moment where I went, oh, okay. So solar panels, 200 watts, going into batteries, going back into load. And then my 4 batteries, 27 DC deep cycle marine batteries, and they're all wired in parallel, obviously. And what I had done was I had taken, let me show you, well, those cables that come with it, and I had, where the white wires are now, I had a red one and a blue, positive, negative, or whatever. Yeah, that's on the positive lug, red one on the positive, black one on the negative, and I hooked it directly up to this. This is 6, maybe 8 gauge cable, 6 gauge or 8 gauge, whatever. And I plugged it directly into the inverter, flicked it on, and the very first thing I did was I turned on this. Now, here's the difference. I had plugged this into the inverter, I plugged the inverter into the charge controller, and it will not run anything. All it does is it starts beeping and shuts off. So instead of running, well, 30 amps means 30 times 12 is 360. So that's the number of watts that this thing was given the opportunity to provide to load, and that's why it kept failing, because this is asking for 600 and the inverter only had 360 available to it, so it chirps, shuts off, I complain. But now with the small cables, I'll get to it. With the small cables, I turned it on, I then turned on this, and the inverter handled it like a champ. That turned on, and then I turned on the beer fridge. And as I was performing this load test, I was watching the charge controller, I was watching this number, and which is the charge on the batteries. I watched that number just tanking. So the inverter can handle it. It has the amps that it needs, but the battery bank is too small. But then as I did a heat test just to make sure all my lines were okay, I put my hand on everything. And when I went to touch the negative cable, the lug was melted and the battery terminal was melted. This was so hot, I couldn't touch it. So instantly freaked out, shut everything off, and then I went back to YouTube and said, what the hell? Couldn't find much, but it turns out that the number of amps determines the size of the cable. So I was obviously pulling more amps through the cable than this cable could handle. I don't know if I can focus on this. Okay, looking for it. This cheap Chinese stuff, it's kind of hard to see. Oh, there it is. Okay. Can you see that this cable is rated for 100 amps and it melted when it was under my load test? And that tells me that more than 100 amps was going through it. I talked to my electrician buddy, and he said more than 100 amps. but he can't understand what caused it. So anyway, I went online and I found the math that says if you're putting 5,000 watts, 5,000 divided by 12, let's say, well, 5,000 divided by a fully charged battery bank, which should be about 13.7. And you're dealing with about 400 amps if I have this thing fully loaded. If I have a continuous draw of 5,000 watts, this inverter will run for about a minute before it chirps and shuts off because it's just too hot. So if I run at about 85% of that continuously, I'm putting nearly 400 amps through those cables. Now keep in mind that this battery bank can't handle that, and I only have 2 solar panels which can't top them up in time. So this will literally kill my battery bank in like 3 minutes. But the point is, those are 4-aught cables. And I did another load test, and as much as this continued to tank, there was absolutely no noticeable heat in those cables because obviously with bigger cables, there's less friction, more amps can flow through it. This is pulling 400 amps, 416 when it's fully loaded. So that was the eureka moment that I had. And as much as any electrician in the world is probably going to criticize the heck out of what I've just done here, it's not permanent. This is simply just, well, taking basic safety in mind. Grounding cable. No, okay, I haven't done any of the basic safety stuff yet, but when this is done, it will be properly, it'll look better. And I will have hardwired, every time this turns on, over on these lugs, I will have fire safety. So I'm going to say smoke detector, fire alarm, and emergency shutoff. So even if it's on, I'm going to wire a shutoff and like a disconnect switch. So if this turns on the smoke detector and the smoke detector goes off, it turns on the fire alarm, and the fire alarm, well, it's all run on series, and then it's going to shut off the power automatically. So this is going to be an automatic disconnect. That's down the road a little bit, but this video is just to let you guys know that I think, figured it out. I need more solar panels to give me the amperage to keep them topped up. I need more batteries to allow me to perform reasonable amounts of work. And just on a side note, outside right now, I have guys who I've hired to fix the foundation of the house because there's water leaking in the spring. So they've got it all dug out. And you can look at my Facebook for some pictures of that. But when they were cutting the concrete, they were using concrete saws and jackhammers. And they didn't know it, but they were all running off this inverter. I had a jackhammer, which was surge wadding. Sorry that I can't. Okay, I can do this. 2091 at full draw. And that was where, that was what the jackhammer was pulling. And this inverter handled it like it was nothing. Anyway, this is my story. I'm sticking to it. My electrician doesn't believe that 400 amps are going through that because he's telling me that if 120 volts and 15 amps are coming through here, that means that's all that's going through there. But there's a whole bunch of stuff inside of this thing that I don't quite understand yet. I'll send a link. I'll put a link on the bottom of my video to an electrical engineer who's wicked smart, and I've watched his video 3 times and I still don't understand it. There's a lot going on in that thing, and there's a lot going on in that, and even batteries. Understanding the anatomy of all 3 of these components is a necessary part of doing this, and I'm just taking baby steps. Anyway, that's my video. Thanks for watching.